So, welcome to the third energy talk. My name is Magda Zafiropoulou, and I'm the Dissemination and Communication Leader of SINNOGENES project. So, in the third energy talk series, which are promoted by SINNOGENES, AGISTIN, iSTENTORE, and TULIP projects, these are projects under the same call, we'll be exploring the battery technology for reliability of power supply. So in this talk that is currently hosted by SINNOGENES project, we will be looking at different battery storage technologies that can be utilized to ensure seamless power grid operation. So starting with the ladies of the panel, today we have with me Mrs. Nana Apostolidou, who is an electrical engineer and computer engineer specialized in power systems. And she's working as a research associate at UPTech Energy, and she's the technical manager of SINNOGENES project. Hello, Nana.
Hello, Magda. Hello, all.
Ariana Martin, she's an electrical engineer, and she's specializing in energy, and she's currently working as an innovation developer at CapVat, who is a partner at SINNOGENES project. Hello, Ariana.
Hello.
Welcome.
Hello, all. Thank you.
He's a guy who's a co-founder and the CEO of Geyser Batteries, that is a partner in AGISTIN project. Welcome, Andrei. Nice to meet you.
Thank you. Nice to meet you all. Looking forward to our discussion.
We have with us also Mr. Francisco Arredondo, who is an assistant professor at Universidad Carlos III de Madrid in Spain and is a partner in iSTENTORE project. Hello, Francisco.
Hello to everybody. Thank you for the invitation to the talk.
Thank you for joining, and we will be discussing the critical role of battery storage in modern grids. And I would like to pass the floor to Nena Apostolidou, who will be moderating this conversation. And of course, during our talk, feel free to use the Q&A session to post any question you have, and we will be addressing them at the end of this talk. Thank you. Nana, the floor is yours.
Thank you, Magda, and thank you all. I'm glad that we are here today. Let's start with the basics. Why batteries? Why do we use batteries? Why are batteries increasingly being integrated as the primary energy storage solution? And in many ways is also, let's say, a core solution in hybrid systems. I don't know if Andrei, you can set the pace.
Yeah, as a battery guy, of course, happy to take this question. Well, batteries are coming to play because of the combination of the speed of the battery reaction, the flexibility that they can provide, the kind of relative ease of deployment from the infrastructure perspective. You can't build, for example, hydropower plants just because you want it. You must have a river for that. And with the increasingly low cost in battery manufacturing, of course, this technology becomes more and more accessible. But of course, primarily batteries are increasingly coming into play, or electrochemical energy storage technologies, because the requirements for grid stabilization are growing and kind of getting more and more complicated all the time. So, for example, in the Nordics, until recently, for example, energy grid flexibility, the frequency stabilization was easily done. 90% of it was done with hydropower plants. Now, after some years of kind of growth in the deployment of renewables, the complexity of grid frequency management grew so much that hydropower became not enough for that. So it's just too slow. And it started losing ground to batteries for that reason. So it's both the complexity and the scope of the challenge and the increasing availability of batteries that make them more and more a solution of choice. I think so. I think Ariana is actually best to comment on that, because basically that's your bread and butter, looking at different technologies and just using batteries whenever you really need them, not because I'm pushing them.
Yeah, actually, I have a very fun story. I always remember about this when I talk about the integration of batteries in electrical system. I remember that some years ago, I was at university and I have a teacher who asked the classroom about if we knew at the time when the energy that we're actually consuming at that moment were produced. And I remember that all the students start shouting answers like, I believe it was 15 minutes ago, 2 hours ago, 2 minutes ago. And at some point in time, the teacher did a little smirk and answered, no, the energy that you are actually using right now, it's being produced right now. And this is only possible because we have really reliable forecast systems, and we have a huge control operational system that makes the electrical system reliable and provides energy in a continuous way. I believe that batteries come to change this paradigm, because if this conversation was today, the answers of the students were right, meaning that batteries are the first step to make sure that now we can use the energy that was produced some time ago whenever it's useful for us, not only in the technical perspective, but also in the economical perspective. And I think that this is something that we didn't have in the past and we have right now. This is the first step to have a reliable, but also to have autonomous way of producing energy. And this is very important for us as energy producers, but is also very important for the grid, because what we are saying is basically that we now have the capacity to do every load shifting that we desired in order to have access to energy whenever we want. Even knowing that, for example, Andrew was talking about the Nordics, and we have a completely different situation in Iberia, where we are dealing with very specific market scenarios, pushing us to the limit in terms of renewable production. And batteries can also be a solution for that. And maybe Francisco can give us some insights about this situation.
Thank you, Ariana. I totally agree with Ariana and also with Andrei's comments. But related to the Iberian case, at the end we have no some. I mean, we are not Norway, for example. In Norway, they have many hydropower plants, so the transition to the renewable. Like 100% renewable power system is very easy for them. But in our case, we need to rely on solar PV and wind power, and at the end they are like variable renewable sources. So at the end we need batteries. What is happening now? What is the situation now in Spain? In Spain and Portugal, as Ariana was saying, due to the high integration of solar PV mainly, the prices of electricity are like close to zero and even negative at some hours. And this is provoking, I suppose, problems for investments, and at the end, if we want to move, if our goal is to move to a 100% renewable energy system, we need batteries. We need batteries for that. Is the only solution that I see, at least technical viable now. At the end, also sometimes we think about batteries as a source to balance the generation and demand, but also batteries can provide more services. And sometimes when we are studying the let's say the payback of the investment in a battery project, we sometimes only take into account the ability of this element to balance the generation and demand, but also they can provide other services, ancillary services, frequency support, reactive support in case of needed to stabilize voltage, and all this capacity due to the integration together with because at the end batteries are connected to the grid with power electronics, and this power electronics they provide some capacities that also is a plus, and it should be regulated because maybe it can provide the investment, the plus needed that the companies and investor will think about investing money in these technologies.
Yes. Yes, I see the point. So definitely, definitely, we have batteries. We have batteries either as standalone storage means, either in hybridized storage structures. I don't know if maybe Ariana, if you want to give us an example about a hybrid storage system that uses batteries and other technologies. I don't know.
So as Francisco was mentioning, I think that the hybridization using storage, especially in Iberia, is going to be a key solution to solve some constraints, because as you all know, and this is not specifically to Iberia, we as Europeans, we have very specific targets for decarbonization. This means that the easy solution is always saying, okay, we really need to increase the renewable penetration. But in order to do that, it's not only possible to build new power plants. It's not only like I'm going to build new PV plants, new wind plants, because this is going to have a real and serious impact on the grid and the way the grid operates, and on the reliability of the grid. This is the technical part. And on top of that, we also need to think that on the production side and on the electricity providers, we need to think on the economical part. We need to have energy in a sustainable but also in a fair way. So it means that if we want to invest in the grid, we need to make sure that this is going to have a fair compensation for that, to provide a fair service. As Francisco was saying, here in Iberia, what we have right now is, due to the PV penetration, we have a huge penetration of PV in specific hours of the time. It pushes the electricity prices to the limit, meaning that we have a lot of hours in the day. And just for letting you know, we are in June, so we still have a summer in front of us. We are saying that during, let's say, 8 hours of our day, sometimes we have prices near zero or below zero. This means that obviously we need to shut up the PV plants. And this is like some paradoxical situation, because we really want to increase the PV penetration, but at the same time, this does not make sense because we need to have our operational plants off. How can we solve that? There's only a way. It's including storage. It's doing the hybridization. Otherwise, we are going to lose the opportunity to produce clean energy. Because batteries give to us the possibility to take that energy and use this in other times of the day and with a fair compensation. Plus, also, as Francisco was mentioning, this is more like an economical perspective, but it's also important to think about the technical perspective, because right now, if we are talking about multiple decentralized productions, we are pushing the grid to the limit, meaning that in most of the times we have specific areas of our grid that are working above the limit for transportation. It means that if we want to have more decentralized production, we also need to make sure that we are going to, let's say, split the electrical efforts of the grid. And we really need to make sure that we have proper equipment to provide, for example, voltage regulation to solve grid constraints. And this is only going to be possible using storage. So it's a reality. If we want to increase renewables, we need to make sure that storage is the only way to do it in a reliable way.
Yes, Ariana. I think that that's the main point.
I think I would like to add to this a little bit. Just, I think it's important to clarify for ourselves, for the audience, just to not to confuse things. First, I would really distinguish between energy storage as a means of energy storage and batteries, because it's a class of solutions, energy storage solutions, and batteries is just only part of that class. So batteries are more about either very fast or very short term to few hours storage. And on top of that comes a host of technologies for long duration energy storage, or simply not even kind of energy storage in an obvious sense of this word, but ways to deploy energy, like hydrogen electrolyzers, all sorts of power to X. Well, pumped hydro would be the energy storage. So the ways to get rid of this excess of energy or deploy it in some economically sensible way and set the floor for the price that would make sensible, again, introduction of more and more of renewable storage. So if in the Southern Europe the problem is solar, in a way, because basically it is constrained by the hours of the day and there is clear overproduction. In the Nordics, particularly, for example, in Finland, where I live and where Geysir Batteries is based, the similar problem, kind of good problem to have, is the wind. So it's either no wind or just massive amount of it, and again we fall into the zero negative prices. So to really handle this problem of overproduction, we have to talk about hundreds of megawatt hours of energy or gigawatt hours of energy. And this is something that you cannot solve with batteries. This is only about power to X and long duration energy storage technologies. Batteries, on the other hand, provide very important function to the grid, which is short-term flexibility, so balancing supply and demand in the short time frames. And with this perspective, there's a growing need for batteries, again, because of renewables. But this is a separate problem from storing of excess of energy. So batteries are helping to solve one problem, the excess of energy, by providing kind of ramp up, ramp down rates for power to X and long duration storage. But also batteries directly solve another problem, which is short-term flexibility. And this problem emerges as we switch from burning basically organic fuels. So until recently, and this is going back to Ariana's earlier comments, we were living in the framework where we had fairly predictable consumption, actually very predictable consumption, and highly controlled production. So the grid could be perfectly regulated so that every moment you consume what has been produced almost at the same moment. Now we're moving into the situation where we have increasing amount of renewables, which are not predictable by their nature. So we cannot predict when we have excess, or cannot regulate. We can predict, but we cannot regulate when we have excess of energy and we have lack of it, particularly with the wind, for example. And at the same time, the consumption is becoming more and more flexible. There are all sorts of technologies where the consumption can be managed by virtual power plants, where consumers suddenly become prosumers. They generate energy themselves. So the complexity of grid became increasingly growing immensely. So for that batteries are required to handle these short-term misbalances?
Yes, thank you, Dre, for this completion.
In this case, I agree with Andre that battery is not the only energy storage solution to be considered to solve all the problems. But specifically in the case that we are talking at the end, we are like the southern people. I see majority, so we are going to impose our examples. But in this, when we were talking about the sample that we were talking about, the Iberian, in Iberian is really a specific case that maybe when the PV fall down because of the sunset, it exactly the same moment that we have like the peak of demand. Because exactly is when people finish work, go home, start to cook, start to, the light in the street. So exactly when the PV drops, we have the peak of demand. So in this case, the solution is to connect many, at the end, in our case, is to connect many combined cycle power plants, like gas power plants, that maybe they will be working like for 2-3 hours, 1-2-3 hours, just to solve this peak demand, and then they will be disconnected. At the end, this plant, they have really high starting cost, and more if they are coming from the cold start or warm start, not hot start. So maybe for this long-term flexibility, I think, or we believe that batteries can be useful, and they could be, but just for this short term, of course, not for moving like large amount of energy from long periods of hours, but just for this short term, just for the moment when the solar PV drops, that exactly is the moment of the high peak demand, 1-2 hours. I think batteries are a good solution. It could be a good solution. This, and I think this is involving the hybridization of renewable projects. Apart of that, also, I would like to just in this case of peak demand, sometimes this can provoke in some distribution networks or some power lines congestions, and due to that, this is provoking also like renewable curtailment during 1-2 hours. At the end, batteries for these cases can be also a solution, can be seen as a solution. But at the end, in our case, or as far as I know, there is no regulation for that. Also, at least in our case, in Spain, there is still no regulation for that. There is still no regulation for battery to provide ancillary service, like frequency response. At the end, the increased penetration of renewable is decreasing the total inertia of our power system, and this is creating that many times renewable curtailment is just to ensure enough inertia in the power system. So considering this fast frequency response of batteries that they can be provided as they are connected with power electronics, this could be part of the solution. This is just a little bit the things that I would like to add.
Yes, Francisco, actually you are very right, and thank you for saying this, because now in all let's say projects and all the research that is being developed, let's say, we see that first of all there is the increasing demand for storage integration into the grid. Batteries is a dominant technology, and also there is a gap in many countries, in many member states, at least in Europe, regarding the connection grid codes. So there must still be many steps in this direction, as you mentioned. But talking about batteries, we have the different batteries technologies, at least for the electric vehicles and for the grid support. Maybe, for example, in the SINNOGENES project, I am I am aware of some different battery technologies that are being studied. Some of them are mature, but some others are beyond state of the art, let's say. Maybe this is a good opportunity to say a few words about some dominant technologies in the battery sector. At least these ones that can support grid operation, as we are explaining in this conversation.
If I may?
Yes, of course.
Yeah, so first, I think it's important to say that there is no such thing as one ideal battery technology. So every battery technology is good for its own purpose. And there are principally kind of three key characteristics of different battery technologies, according to which you select one. It's how much energy per euro or per kilo, well, per kilo or per liter, but at the end of the day, per euro you can store, how fast the battery can release it, and how many times. And from the balance of these three characteristics, lithium-ion was, of course, a breakthrough. So this is by far the most flexible technology that can solve a lot of different problems. Not necessarily all of them would be solved most economically, but the fact that you can deploy the same battery in different kind of format provides you an opportunity to offer different services or different kind of performance. Say in the stationary storage, that would be called revenue stacking. From you can store energy for a longer period of time and sell this as a service, or you can provide faster response and sell it as a different service to the grid operator. However, the lithium-ion technologies, while being great solutions for today, they appear to be kind of more and more problematic of a solution for tomorrow, and also probably less relevant for many applications. As we discussed, there is kind of two kind of polar challenges in the grid regulation. One is storing energy for long periods of time, and the other one is storing energy for short periods of time and really balancing this, for example, supply and demand to maintain frequency in the grid. And lithium-ion technologies are most efficient for doing the energy storage over hours. So like PV case, 4-hour storage, that's an ideal case. If we're talking about longer duration storage, we would go just for other technologies by default. So in that perspective, we can talk about the dominant technology of today, but then the needs of the power grid are changing as well. So what is dominant today will not necessarily be dominant tomorrow, just because the tasks are changing. Plus, with lithium technology, if we think about just scaling them endlessly, we end up with a massive dependency on China in terms of the supply of batteries, because basically what has happened already de facto with batteries is the same that has happened with solar before. So there is massive overcapacity in terms of battery production in China, which allows to produce at much lower price than that would be economically feasible for a new lithium-ion gigafactory in Europe. So increasing the scale of lithium-ion deployment will just increase this dependency. Lithium-ion is great for cars, but for stationary storage, there are lots of kind of alternative technologies that need to be pushed and deployed, for like redox flow batteries, like all sorts of Power-to-X technologies, alternative batteries that are developed in Europe. Plus, we should really focus on technologies that can be reasonably scaled in kind of planetary scale. So there is no way we can store all the energy that we need to store with lithium-ion batteries, just because we don't have enough lithium, cobalt, and we will inflate the price of nickel to the limit. So And on top of that, we end up with a lot of highly toxic and flammable waste from lithium ion, which is still a challenge how to recycle it economically and at scale. Manufacturing of lithium ion batteries is massive greenhouse gas emissions unless you produce them from renewable energy, which you would rather probably deploy otherwise. So we can do better than that. And probably all of the Horizon Europe projects that we are representing here are one way or another focusing on hybridization of greener technologies to provide better service with the solutions that are more targeted to specific use cases, not going one for all solution like lithium ion, particularly so that it's not solving all the problems, but most of them, but making really a bit more efficient solutions and figuring out how to scale them economically to really compete with lithium ion also on the price basis. But policy plays a big role in this, and from the policy perspective, the EU is also moving in the right direction. So there's a new EU battery regulation that is really favoring greener, longer duration technologies with no recourse to critical raw materials, with more secure supply base, with lower greenhouse gas emissions. So there is a policy support, and we just really need to figure out the integration of different greener technologies to be able to deploy them at scale. So yeah, I sort of dodged your question about the prevailing technology. It is lithium ion.
I just want to have it. You mentioned, Andrei, I think a very important topic in the previous question. I think that we are providing an overall perspective on integration of batteries on the electrical system. But you mentioned virtual power plants, and for me this is something really important because right now we are talking in a macro perspective, but in the a focused perspective of the virtual power plants, meaning using batteries to create a way of producing energy regarding decentralized solutions. This is even more important because what we are saying is if I want to create a virtual power plant using a specific battery storage, this is even more important because I know for sure that I have a very specific kind of consumption, and regarding that, I will use an appropriate type, an appropriate technology for this kind of solution. Just to give you an example, as Andrew was mentioning, I think that lithium-ion batteries are the most cost-effective, let's say, for sure, and we all agree on that. But if, for example, if we think about creating some specific facilities for renewable fuels production, where we are asking for long discharge times, for example, if I want to have a facility producing 24/7, for example, and I want to store my energy and I want to use it during a long discharge time, for example, we can be looking for flow batteries, and just to mention that this is the case of SINNOGENES. Despite we all know that lithium ion batteries are very well known and they are already very well developed in terms of technology. For example, in SINNOGENES, we are now looking for pilots regarding flow batteries in order to be able to model the behavior of the flow batteries and to make sure that this kind of technology can be used in very specific scenarios with very specific requests in terms of industrial facilities and demand.
Yeah, I agree that virtual power plants are a solution for all these problems because they can combine different technologies. At the end, it depends on the specific requirements. So it's better, it's more suitable some technologies or other technologies. From my perspective, to advance in this I think. We expect policy because at the end, at least here, policy is needed for that. In the case of the project of the demo, for example, in the project iSTENTORE that I am, the idea was that the idea was to combine forming a virtual power plants, lithium ion battery, flow battery, and together with a hydro, and forming a virtual power plant and do some demonstration of the capabilities of that for different kind of situations of problematic. And I think in this sense, I totally agree with my colleagues, with my partner that we have to advance in this way. Regarding the lithium ion technology, for example, before I was talking about the problematic here that we have, like for giving examples that I think sometimes are more visual. For example, the specific problematic that we are describing before between Ariana and me here in the Iberia, that the sunset, suddenly the peak demand. For example, this problem is mainly solved in California. During this hour, they connect massive amount of lithium batteries. And nowadays, during many days, the main source of energy in the California power system are batteries during this hour, just 2 or 3 hours, because they use all the solar storage during the day, and during this peak demand, they enter and provide the service. But yeah, this is limited. At the end, this technology can provide the service for a reduced amount of time. But yeah, I totally agree with my colleagues about all that they were putting into the table.
Nana, you're muted.
I'm sorry. Actually, as I hear you speaking, I see that we have different requirements, different applications, different battery technologies, and of course, always before you test, you test the battery technology for the specific application that you want to test it. You have, of course, to design and model before. This is the first step, and I believe that in the audience we have many researchers involved. Also in battery modeling. So maybe because we and Francisco and Ariana are from the academia sector, let's say, maybe you can give us some high-level information about the state of the art in the battery modeling, maybe some information about some good models, some techniques or some software that you are using, and maybe we are lucky enough and you want to share with us some new results, some good news from your research.
I don't know, Francisco. I just can give you an overview because, in fact, in SINNOGENES project, we are working closely with Inesctec regarding the modeling of batteries. And I'm just going to give an highlight because I need to admit that from the electrical engineer perspective, batteries seems like a walk in the park. Despite I know that they are not, because we are looking to model the battery in order to use the battery and not to consider all the complexity behind the battery itself. I think that modeling a battery is something really complex, and despite from our perspective, we are always looking forward to use it. It's really important to consider multiple variables and multiple factors when modeling a battery. we are talking about something that has an electrochemical model. We are talking about thermal efforts. We are talking about aging and degradation. And I'm just talking about three main topics that are already too complex and involve a lot of variables to be included. But this has an expression in terms of maintenance and also in terms of the degradation of the battery. And this is something really important for us, the ones responsible for operating the battery, because for us, it's not only important to know what kind of battery am I going to use for a specific application. I know how to use it. I need to know how to use it. I need to know how should I try to use it in order to preserve the life of the battery, and of course, in order to maximize its use. And I think that even this is complex enough, but if we think about the economical part on top of that, it's even more complex, because if from one side we have all the technical constraints, we want to include the economical constraints. And what are we talking about here? We are not talking about the degradation and the lifetime and the thermal behavior. We are also talking about how can I optimize the use of my battery on a daily basis. So should I use my battery for trading energy? So basically storage the energy in the cheapest hours and selling it on the most interesting hours in terms of price. Should I use it for providing flexibility services, as Francisco was mentioning? Should I use this for providing specific services to the TSO or to the TSO? And you can see it here that it's even more complex. So I think that probably this is one of the most complex parts of using a battery. It's to create an end-to-end solution capable of modeling all the behavior from the beginning of the behavior of the battery until operating it and including it on electrical service. And this is something really complex. It's something that we are trying to address, at least from Capwatt's side. We are trying to address this with other partners in SINNOGENES project, and it's something that it's going to be used for sure even after this project, and it's something that it's really important for raising this battery business.
Well, in my case, starting from the beginning, we were talking about like modeling batteries for the studies. I think this is a very important topic, very important like point that you bring out. At the end, it depends on your needs. It depends. You want to make an investment project, if it is profitable to invest in a battery for one location, or you want to make a project to calculate the optimal operation of a battery that is already installed. So depending on the goals, also if you want to focus only in the specific project of the batteries, or you want to see how it affects to the whole system. So depending on the study that you face, I think you need to use some kind of models or another. Of course, what we see, or at least what we see, I was supervising some bachelor thesis and master thesis, and we were studying about the profits of batteries for doing, for example, arbitrage. In the arbitrage, I suppose maybe everybody know what the meaning of that is: just buying energy when the prices are low and selling when the prices are higher. So we see, or we demonstrated with our calculation that it's not profitable for batteries. But what we see, our conclusions is like, okay, we combine this with providing frequency or regulation services, like frequency fast response, frequency response, even secondary frequency regulation. So this project could obtain extra profits that they could make them to be adequate, or this kind of profits from the ancillary service can push up this project. It's maybe just the small push that this project needs to be adequate. So this is more or less what I could say. In general, when I'm working about optimization, of course, I think it's very important to consider the aging and degradation lifetime, and to model precise this, because at the end, depending on how you use the battery, so you can really reduce the lifetime of battery, and this will affect to your project.
Yes, and thank you, Francisco. And as you both highlighted, of course, it is not one man show here, because there are different sciences that have to synergy to complement each other. Chemical engineers, electrical engineers, to put the perspective for the of the uses of the battery and the performance, and be combined to deliver the solution, the final end-to-end solution, as you said.
Just highlighting the comment of Clara from Inesctec. I think that she was clearer than me explaining actually the modeling part, because right now, as she is mentioning, we Inesctec already developed a modeling capable of including degradation and efficiency on the way the battery operates. And for us, this is life-changing, because it's almost impossible to operate the battery in the most efficient way without considering these factors. And right now, on top of that, they are even developing the economical part, providing the intelligence to know exactly how and when we are going to operate the battery. And without that, I would say that it would be impossible, or at least it will not be efficient enough to use battery storage systems on the grid.
Yes, this is very important, Dušan. Thank you, Clara, for your comment.
Magda, you're muted.
Magda, we don't hear you. Still cannot hear you.
Nope.
Nope. No, now you're muted. Please check unmute. Magda, unmute.
I think if you're using the Teams via your browser, it's your browser that doesn't have microphone accessible. So
okay, yes. Okay, maybe she will join again. I see. In the meantime, I see that we have some comments in the Q&A session. It's of course Clara's comment. Also, we have some previous comment from Matian. Thanks, Andre, for the insight on LFP batteries and the strategic and geopolitical role they play today. What kind of technologies do you think of when you talk about more sustainable and more local storage systems? Sodium batteries, water storage? Andre, I think this question targeted for you.
Well, I can talk about the type of hybrid energy storages that we are working on. So basically, gas batteries is not a competition to lithium-ion per se. So we are the greenest and cheapest megawatt-minute energy storage. We are not a solution for storing energy for hours. We're more like power buffer. but we're doing this at the lowest cost for the minute duration, which is too long for supercaps and too short for lithium-ion batteries, and with no recourse to lithium-ion technology, CRM, no dependence on China, etc. And the way we see the kind of grid scale storage evolution is towards hybrid solutions between technologies like us, so for short duration energy storage, and for example, within this AGISTIN project that I'm presenting in here, we have two demos. One is with pumped hydro, and actually innovative pumped hydro in Spain. Irrigation channels will be used after this project as the way of energy storage, so pumping water up and down depending on the excess of energy. And of course, that would not be a solution to regulate the grid unless that would be a really fast reacting type of energy storage. So we complement the a solution with the high energy capacity but low flexibility with our battery that has lower energy capacity but very fast reaction times. Another solution that we're developing in AGISTIN project is complementing hydrogen electrolyzers with Power2X. Again, that's a way of getting rid of the excess of energy by storing it in hydrogen using for other types of electrification and or even load shifting within the grid if using this hydrogen for peaker sort of peak demand in the grid. So that kind of technologies that we're talking about. Plus, there is a whole raft of emerging long duration energy storage technologies, as you know, with actually quite good backing and funding from also from private sources. They all can serve the purpose of grid stabilization if they could be fast enough and durable enough. So we, as a sustainable, low-cost, fast-reacting technology, complement them to deliver a complete solution for the grid. Of course, the challenge here is how to ensure the final solution to be economically effective. Because, as I mentioned, the lithium-ion has been brought to rock-bottom prices by massive overproduction in China. And this is not an easy kind of game to play, but the core fundamentals of this technology, particularly supported by the essentially zero marginal cost of energy from renewables, does make this large-scale hybrid energy storage deployments feasible economically.
Yes, obviously the state of the art points a hybrid solution. We cannot solve everything under one technology. This is clear, and in my opinion, this will be the case. Okay, Etienne, thanks you so much for the answer. Thank you too. We have also one other interesting comment plus question. This is from Manuel. On the power system studies perspective, are there any international standards documenting generic fundamentals for modeling? Are OEMs delivering proprietary models for grid code compliance? Well, this is quite interesting. A question.
And technical.
And technical. Yes.
Francisco, I think only you can save us.
Well, I'm not aware of that. I'm not aware of that. If you are, I would be interested in obtaining that information.
Wouldn't be a battery model specific to battery or energy storage kind of technology, in case of battery specific to electrochemistry. Are we talking here about the requirements from the grid or about the battery model? I'm actually not sure.
Well, I guess from the perspective of the grid, at the end, the grid is from the perspective of the grid, a battery is exactly the same that any other renewable power plant connected through inverters. At the end, it's like power electronics, and the grid, the vision of the grid is just the power electronics. What is behind is actually not affecting for a grid study. At the end, you stop in the.
I will probably have that this lies on the lack of regulatory specifications, because I agree with you, we are talking about power electronics, but there's a fact that it can be probably some misalignments in terms of grid operation. So we mentioned a lot of times during the conversations, at least as far as we know right now, there is no specific policies for the integration of batteries. I'm not sure if it is because they are not needed or because they are not well developed yet. But for sure, that I believe that with massification of this kind of equipment in the grid, I believe that political entities will be able to develop some regulatory documentation for it. But
Yes.
I agree with you, Francisco. I'm not aware of this, and that's the fact. I'm not sure that's if it is because it's not necessary or if it is not well developed yet.
Yes. Yeah. Okay. Clara also is commenting that there are some initiatives, for example, in SIGRE working group towards modeling of distributed energy resources. Yes, and indeed, as the integration of these DERs is becoming more and more tension for the grid, definitely we will have to deliver also the appropriate coding, the appropriate standards, and also to include the functions like fault right-through capabilities of these storage that are behind the inverters and the converters as the power electronic device, as Francisco said. So I think that this is also a hot topic right now. I don't see any other comments, but I think that we had a fruitful discussion. I would like to thank you all at this point, both the speakers and the attendees of this meeting. It was nice to see you and have this conversation.
It was
Yeah,
great.
thanks for having us here.
Thanks, everyone.
Thank you very much.
Thank you so much.
See you again soon, I hope.
And yes, stay tuned for the next energy talk that is going to be hosted by Tulip Project, probably in November. Stay tuned as we will announce the date. Thank you very much, everyone.
Yeah, thanks.
Thank you all.
Thank you,
Bye-bye.
everyone.
Bye.
Nice.
Bye.
Bye.